on inverses of trigonometric functions. So our objective is to be able to evaluate, at the same time use these equations and inverses of the trigonometric functions to solve problems. Okay, so let me start out by saying that this is not the same as your reciprocals. If you remember, your reciprocals are the cotangent, cosecant, and secant functions. Now, when you talk about inverses, if you remember, in the past, when we looked for inverses of functions, what you did was you switched the x and y values, and then you solved for the y value. Okay, so that's what we did. So essentially, that's what's happening here. Okay, so in the past lessons, when we did your unit circle, we evaluated for sine, cosine, tangent. What we've been doing was I've been asking you questions like, okay, please evaluate the sine, or evaluate for sine pi over 6. So what you did was you looked for the coordinate of the point on pi over 6. So for the sine value, you found 1/2. Okay, but today for inverses of trigonometric functions, you will be doing the reverse or the inverse. Instead, what I will be providing you is this. For example, going back to that same example, I will say, all right, I need you to find the inverse of sine 1/2. Meaning, okay, I'm giving you the coordinate point right now. Your job is to find the actual angle measure, whether it be in degrees or radians. Okay, so let's get you started. So the proper notation for inverses is when you're using your -1, if you remember. Okay, so remember we did this a while ago, so it looks really familiar to you. All right, so originally we found sine theta, but now we're doing the inverse function. Okay, so let's start with finding all possible values of the inverse of sine, okay, for √2/2. Okay, so here's what you want to do. Here's how you want to start. Referring back to the unit circle you copied into your notebook or on this one on your screen, we're going to locate which point on your unit circle has a sine value of √2/2 so that we can find the corresponding measurement. All right, let's do that. So let's look for √2/2 on the sine value, on the y value, on y coordinate. All right, let me get my pen working right here. All right, there we go. Okay, so we're checking and looking for positive, okay? Take note, the sine needs to be positive. Okay, so we found pi over 4. All right, keep looking around. Look for the y coordinate. All right, y coordinate here is also positive. Okay, so you actually can limit this. Think about this. There are 4 quadrants on your unit circle. When you think about it, which of the quadrants have a positive y coordinate? Okay, you're narrowing down your choices between quadrants 1 and 2 only. And so we can stop there. All right, we found these 2. Okay, so currently we've found pi over 4. All right, and then the other one that we found is 3 pi over 4. Okay, again, we're only limiting to quadrants 1 and 2 because it needs to be a positive value. All right, now that we've narrowed it down, because you're talking about finding all possible values. Remember, in a unit circle or in any circle really, you can rotate. You can do more than a single rotation. So right here, we've added the information that now you've found the actual degree or radian measures. Okay, you don't need to use a degree measure for now. Okay, we're just focusing on radians. You're going to add the integer where there are multiples of 2 pi radians to show the rotation, right? How many times you can go around the circle, where n is an integer. So it will look like this. I can say that pi over 4 will have a sine value of √2/2, but every time I rotate, I can find coterminal angles based on how many ever rotations I make, based on n, how many times I can go around. At the same time, I can also use 3 pi over 4 plus 2 pi n to show coterminal angles this time to 3 pi over 4. And your answer is right here. So these are all the possible values using pi over 4 and 3 pi over 4 and their coterminals. All right? So notice what we did. Now you're given the y coordinate or x coordinate, whichever that may be, and your job is to find the angle measure. in degrees or radians. Okay, let's try the one at the bottom. Find all possible values for the inverse tangent of 1. So now, obviously, tangent, as you know, is when we have to divide the sine and cosine values, or the y and the x values, right? Okay, all right, think about this. In which quadrant, let's start by narrowing it down once again. The tangent needs to be a positive value. Which of the 4 quadrants will contain a positive tangent value? Meaning if you divided the y and x values, you should end up with a positive value. Well, that means you're narrowing it down only to quadrant 1, because 2 positives divided by each other will make it positive, and quadrant number 3, because 2 negatives divided by each other becomes a positive value. So now we've narrowed it down. Let's take a look at the values. All right, so we're ignoring this. Let's erase it right here. Okay. All right. So in quadrant 1, let's look for values. When you divide the y by the x value, that will result in positive 1. All right, so we've located one of them, pi over 4 right here for quadrant 1. Okay, we're done with quadrant 1. Let's check out quadrant 3. All right, so observe when you're dividing the values, you need to get a 1, and there we go. We found 5 pi over 4. So in the same manner, not only are these the only angle measures available that will result in a tangent value of 1, you need to consider their coterminals, right? Angles that allow you to go and create more rotations but still end up on the same location. So we say that all possible values will include pi over 4 plus 2 pi n, all right? It just so happens it's almost exactly like the one we have on top, all right? That's okay. And the other one is when we are using 5 pi over 4 plus 2 pi n. Again, this is because the question is asking us to find all possible values. So we need to indicate the 2 pi n part to show the rotations. All right? So this is one of the objectives that we had to be able to evaluate inverse trig functions. Let's bring you forward. Okay, so now the issue is this. When you look for inverse trig functions, right, trigonometric functions, there are so many possible answers. For example, you just found that root 2 over 2, okay, let's go back just a quick second here. Root 2 over 2 for sine, for example, for the y values are actually found in multiple quadrants. And what that does is your inverse values will not become functions. Because as you know, for functions, it needs to be a one-to-one relationship. Because of that, it's just a relation. So in order to achieve a function, okay, an inverse function, what we will be doing is we're going to limit and provide a specific domain and range so that we are producing a function, all right? So that's why on your notes, when you try and read your book, it says here, it is necessary, okay, to restrict the domain in order to define a specific function, a specific inverse function. That's the only way we can narrow this down, okay? All right, so that's the difference. If you're instructed to find all possible values, then you take note of what we did in the previous slide. However, now that you're actually talking about inverse functions, you need to narrow it down and follow the specific information on this table. Okay, so now this is one of the things that I am asking you to write down in your notebook. It is very helpful to have this available and to refer back to this table. Okay, so take a look. In order to show an inverse function, all right, notice how in the past we used a lowercase function or our lowercase letter to show the function or the relation. Now we're going to be very specific. We're going to use an uppercase letter. Notice how sine here, the S is an uppercase letter, cosine and tangent. That's the main difference. Now this will signify that you're actually looking for the inverse function. Okay, a specific one where you have a limited domain to produce a specific function. All right, so in the same manner that you did, take a look. All right, your domain for sine is limited to the values between -1 and 1. And the same thing happens for cosine. Okay, what does that mean? For -1 to 1, for sine, look at the sine value. The sine value are the y values. Think of the y values. The y values start from -1, right, to +1. On the other hand, when you talk about the range will represent the angle measures, your radians and degree measures. And they will range only between these two quadrants. Okay, so that's what it means to limit or to provide restrictions so that we can produce functions. In the past, okay, for the past example, you found sine in many different quadrants. Now notice how because it's a function, we're limiting it to only quadrants 1 and 4. I do not want to refer to it as a very specific quadrant 1 and 4, just because when we go into the tangent function shortly, you will see that it won't be quadrant 4, rather it's still quadrant 1, but it's the different rotation, okay? All right, so let me remove the quadrants, but just so you know what locations I'm describing, okay? For cosine uppercase C, this time you're narrowing it down to these two top quadrants. Let's refer to them that way, two top quadrants. And when you're looking for tangent values, it looks very similar to the sine values, okay, the inverse sine values. But the main difference is this. All right, ready? That's why I didn't want to call it quadrants 1, 2, 3, or 4 at this point. It's because of this. When you talk about tangent functions, notice how the values range from negative pi halves to pi halves. What does that mean? When you talk about values down below in this quadrant right here, you're actually considering a rotation which is going a clockwise direction, meaning your angles will produce negative measurements. So, in the same manner, if you talk about the degree unit, it will go from negative 90 to positive 90 degrees. So these right here will be your negative 60, negative 45, negative 30. All right, so instead of saying there are 200 or there are 300, 315, 330 degrees, no, they're actually going to be the negative angle measures like the ones we mentioned, okay? So that's the only difference for tangent functions. So let's actually look at how we can apply these now. All right, so right here, evaluate each inverse function and give your answer in both radians and degrees. Notice how it actually specifies, it instructs you, okay? So this one, you're looking for an inverse function. You're going to use the restrictions that we mentioned in the previous slide. All right, let's start with cosine. For cosine, for inverse cosine 1/2, okay, go back a little bit. For cosine, we said we need to narrow it down to the top two quadrants. All right, so we're narrowing it down to these two up here. So let's draw it out here so you know exactly where we're looking at. Okay, because it needs to be a positive value, and these are going to be up here. All right, but you see, here's the problem. When you talk about these two top quadrants right here, cosine on quadrant 1 is positive. However, cosine in quadrant 2, or the other one, will become negative. So that means you're narrowing down your answers further by only looking at this whole section right here, this quadrant. All right, so let's look at this quadrant up here. Because you're looking for inverse cosine 1/2, all right, let's look for the cosine value. That is 1/2, and that narrows it down to pi over 3. So we say that, in fact, right here, we're evaluating for the function, and it is pi over 3, or otherwise a 60-degree measure, because it's asking for a radian and degree measure, and that's it. So this is what it means to evaluate the inverse trigonometric function. Okay, you're given the coordinate, now you're looking for the angle measure, right? So it's really interesting that way. And you have options to narrow it down further, just like what we did by looking at the quadrants and addressing what signs are given to us. All right, let's look at sine, the inverse sine of 2. Inverse sine 2 for the function given in B. All right, let's go ahead and take a look at this. So it says 2, all right? Let's recall, if you remember in your notes, we're only referring to these two vertical quadrants. Now think about this. You're looking for a sine value that is a positive 2, all right, which narrows down your options here to the top one. So again, we're referring to this same quadrant, just like the past one. But here's the problem, okay? Let's take a look at these y values, the y coordinates. Do you guys see any 2 here? Absolutely not. Because also, in the past, in the table that we were given, notice how the values for the domain, right? The value you're looking at, 2 is a domain. Observe how the values only range between -1 and 1. So it narrows it down only to those values. And 2 is definitely not within that given set of points. So we say, for this function, right, we say that it is undefined because, all right, let's write it down, undefined because of the fact that the domain is only specific to values that range between -1 and +1. So that's the reason behind why we're saying it's undefined. Also, you can't really see 2 here, okay, if that makes sense. All right, so on the next page, you'll have an opportunity to try and apply what you just learned. So give yourself some time to read the questions, evaluate each inverse trigonometric function, and give your answer in both radians and degrees. At this point, you can pause the video and give yourself some time to answer them. Okay, so for the first one, we're going to look for the sine, inverse sine function. So we're narrowing it down only to these 2 quadrants, right? Okay, so remember, focus. Your sign here is negative. All right, okay, we're narrowing it down further. That means we're actually just using the bottom quadrant right here. Okay, I cannot draw. All right, there we go. So we're referring to this section right here. Okay, but remember, it's a sine function. Remember what I mentioned earlier when you talked about sine values? All right, so go back here. All right, so in the same manner, right, you're using a range from -π/2 to π/2 or -90 to 90 degrees, just like your tangent function, the one we were looking at earlier at the beginning of the video. So that really tells you that we're not using 300, 315 degrees, definitely not, because you're limiting it between -90 and 90 degrees. So instead, you need to think of the reverse, where the rotation of your angle is going in a clockwise direction like this. You guys remember that? All right, which means your angle will become a negative measurement. So let's think about this. Let's relabel the quadrant. So right here, instead of 11π/6, it will become -π/6. The next one is -π/4. Notice how we're using the same measures from the first quadrant, except they're negative. All right, -π/3. Just because we're going in a negative direction and we've narrowed it down to this quadrant, the bottom one, and it needs to be a negative sign. All right, so we found it. So we say that, okay, the measurement is actually the angle for the given function is -π/4, or in degrees is -45 degrees. All right, so that's really what we're looking for. In the same manner, let's move on to the second one. We're looking for the inverse cosine, which will give us a 0. All right, so let's narrow it down further. Okay, start with your unit circle, okay, the one that's been guiding us. As you know, cosine is narrowed down and limited only to these 2 top ones. Okay, but really, when you talk about a cosine value which is 0, all right, you don't really find them in between, but you find them in the corners, if that's how you can refer to them. So right here, the very first one is you have 1, 0. The top one, this top point right here is 0, 1. And then you have your -1, 0. So to say that you're looking for a cosine value which is 0, we narrow down your answer to this top point right here with the coordinate 0, 1. Okay, so we say, okay, well, that means that that value right here is actually π/2 or 90 degrees. Okay, so we've given our answer in both radians and in degrees. So that's what it means to evaluate for inverse trigonometric functions. All right, let's go forward now. All right, so now that you've figured out how to evaluate and how to use your unit circle alongside with the problems, let's look at an application problem. So there's this group of hikers. They intend to go from a campground to a lake, and the lake is actually 2 miles east and 0.5 mile north. So to the nearest degree, we're going to identify what direction they should take. So it really, really helps if you illustrate the situation. So let's say this right here, let's start right here. This is your campground, okay? All right, and we're trying to go 2 miles to the east. So this is me going east, all right, 2 miles. This measures 2 miles. And then we need to go north by 0.5 mile, like so. Okay, so not drawn to scale, but okay. All right, so this will be our lake. This will be the lake. Pretty beautiful lake. All right, so what actually happened is you produced a right triangle right there. Super cool. Just like what you would do or what you did in the past with your angle of depression in the other one, right? All right, so we're going to identify this measurement because we're trying to find to the nearest degree what direction they should take. So this is theta. This is what we're trying to identify. So let's see what you have right now. In the same manner that we did in the past, we're going to identify what information we have. You have an opposite and an adjacent measurement, which narrows down your option to using a tangent function. So we're going to say, okay, well, I guess we're using tangent because that's the only one available to use an opposite and adjacent measurement. All right, so let's write them out. So tangent theta is the opposite measure, 0.5, over 2, yes, right? Okay, and we can simplify it further. So we say, okay, that's tangent theta, which is 0.25. Okay, but hold on, we're not really looking for any measurement, specifically a length. No, we're actually looking for an angle measure. And this is where your inverse function comes into play. So instead we say, okay, so this is how we set up our equation. To solve for theta, the angle measure, we're going to use the inverse tangent function for 0.25. Okay, and no, I will not ask you to do this manually. Instead, you can do this in your calculators. Okay, so making sure though that your mode is in degrees or in the degree mode. Okay, so make sure you do that first before you enter this into your calculators. All right, so when you do, your answer will be approximately 13 point, I can't really remember the actual values, but it's about 13.6 or something. But it's asking us to round to the nearest degree. So we say, all right, they are going to have to go and walk at a 14-degree direction. So from the campground to the lake, they need to take a 14-degree measure in order to go if they intend to take a straight path. All right, so this is how we're actually applying your inverse function. All right, so in the next page, you're going to have an opportunity to try this out. You can pause the video, give yourself some time to practice, and then resume whenever you're ready. All right, here we go. So an unusual rock formation is 1 mile east and 0.75 miles north of the lake. So to the nearest degree, in what direction should the hikers head from the lake to reach the rock formation? So remember, this is a connection of the word problem, okay? So you can decide how, you can start from scratch here, start a new illustration. The previous information we have doesn't really matter right now, okay? So go ahead and pause the video. All right, so we're ready. So we'll start with an illustration. This is the lake. Okay, now we're starting from the lake, and then we're going to the east, like so, 1 mile. Okay, that's 1 mile. And then we have to take north, 0.75 miles. And this location will now be the rock formation. Okay, we're trying to reach this point. And again, you formed a right triangle. All right, we're going to identify the direction they're going to have to take. All right, so this is theta. All right, so they went east and then they went north. Okay, so you know they need to go at a northeast direction. That's all you know right now. You don't know the specific measurement, but you know they need to take a northeast direction. All right, so let's actually identify what we have so we can use the information available. You have an opposite measurement and an adjacent one once again. So that leaves us to a tangent function. So we say the tangent theta function should be 0.75 over 1, or just really 0.75. And if you remember, In order to identify the theta measure, we need to use the inverse function. So we say inverse tangent 0.75 will give us whatever we need. Okay, all we know right now is we're going at a northeast direction, but we don't know to what specific degree. So let's identify that. When you plug this into your calculator, you will end up getting something like 87 degrees, which it's asking for it to the nearest degree. So we say, all right, well, they need to take a 37-degree northeast direction. All right, so that's how you can use the inverse function to answer problems like these. Okay, pretty cool, really. It now combines all that you've done in the past. All right, let's go forward. Okay, so at this point, you are able to evaluate. Now, this part is where you really need to use a graphing calculator available to you, making sure that your mode is in degree. All right, make sure the degree is appropriately selected. There is a very loud motorcycle that just drove by. I'm sorry about that. Okay, so the mode needs to be in degree. All right, so now that you've done that, here is how you're going to approach the problem. Because we're looking for theta, you're going to solve each equation to the nearest 10th, but making sure you follow these restrictions. What's the difference between what we did earlier? What we did earlier was to use inverse functions with specific restrictions that were standard. But now for questions like these, they actually tell you, okay, they actually tell you where to look, which quadrants to use. So we're going to go ahead and do exactly that. All right, so right here, you're going to find the inverse function because you're looking for theta, an angle measurement. So you will say, well, I need the inverse cosine for 0.6. Okay, and you can enter this into your calculator. And when you do, confirm that you're actually getting a 53.1 degree measurement, and then that's it. But before you actually know you're done, you want to do this one extra step. Ready? You need to confirm if that measurement that you obtained is actually agreeing with the restriction provided. Is 53.1 degrees actually within the range that you were given? If so, then that's your final answer. Like in this case, it does agree with the restriction, so we're going to say that's our final answer. All right, let's go try out the next one. It's actually a very similar problem. So we know we're going to end up with a 53.1 degree measure, exact same problem. Here's the main difference. Notice how the restriction has changed from a 270 degree measure to 360 degrees. Okay, so what does that mean for us? Okay, so let me show you an illustration. All right, so this is your circle. Let's locate 53.1. It's about somewhere right here, right? Because now you're focusing on the angles between 270 and 360, that's down here, it's asking you to identify another angle measure that will result in a cosine value of 0.6. Now in this quadrant, what would that measure be? So that's what you're trying to identify. So it's basically like imagining a reflection over here, right? So if there were a reflection like so, what would this angle measure be? All right, so think about this, between 270 and 360. Your options are either, okay, to do the following. You can either add 180 or subtract 180. However, that only brings you over to this quadrant, which you don't really need. But if you added another 180, that just brings you back all the way through. So no, that doesn't work. What if we subtracted from 360? This is what I mean. Because you're looking for an angle measure right here, which will have the same cosine value of 0.6, what you can do, okay, is to take away the angle measure we found, because that would mean it's coterminal with this point that we identified, so that now we can say that, okay, the other angle measure, which will produce a cosine value of 0.6 in this range, will be 306.9 degrees. And you can confirm that by checking. That's how you can check. Go ahead and try it out. If you tried looking for cosine 306.9 degrees, it should be about 0.6. Okay, that's how you can check if your answer is correct. All right, so on the next slide, you'll have an opportunity to try out what we just did. Okay, so you can pause the video at any point. Okay, so solve each equation to the nearest tenth, just like what we did, following the given restrictions. Okay, once again, take a look. The questions are related. It just so happens that they are. Okay, go ahead and pause the video at this time. All right, we're ready. So in 4a, when you look for the inverse tangent for -2, all right, we're writing it down. Okay, so now you are informed, or they're informing us as the restriction is between -90 and 90. And when you evaluated for the given in your calculators, okay, we end up with -63.4 degrees. Now check, is -63.4 within the given restrictions? Well, yes, it is. So this is your answer for 4a. Okay, so that's 4a. Now let's take a look at 4b. In 4b, okay, knowing that will result in the same answer, but now the restriction has changed a little bit. It now is asking you to look only between 90 and 180 degree measures. Okay, let's try to illustrate this. So this is a negative angle measure. That is absolutely fine. It just means that we're going the clockwise direction, going down, yeah? Okay, so -63.4, let's say, is somewhere over here, right? This is -63.4, it opens this way. Now we're going to think again of 90 to 180 degrees. Now where is 90 to 180 degrees, right? All right, so 90 to 180 is right here. So this is where we need to look. Okay, so remember how we said we're looking for something like a reflection? My question for you is, what would be a measurement that would reflect right here? Because we're looking for a tangent value, this point right here should have a tangent value of -2, but we don't know what that is. So earlier, we tried adding and subtracting 180, and then we ended up subtracting from 360 because that was what the question was requiring. But right now, we need to limit ourselves between these values. So what do you think we should do, right? So that's the question we have right now. Well, it's between 90 and 180, and because we're in a positive measurement, we're going to look for this angle measure, okay, by doing the following. You can subtract 63.4 from 180 degrees. Because isn't that anyway the angle measure that we're looking for, which will result with a tangent value of -2. So once you do that, the result will be to the nearest tenth, 116.6 degrees. And these will become coterminal with the same measurement. Okay, so you can check if you were to evaluate for a tangent of 116.6 degrees, you will end up with something close to -2, if not exactly -2, all right? So take your time going through these questions, reviewing them, and making sure that you are actually looking at the specific restrictions, making sure you're following them, and adhering to the requirements, all right? So I'll stop here for now. I'll see you soon, okay? List down any questions you have, and we can definitely address them during our tutoring sessions. Bye for now.